This is worksheet number 2. From Solution Preps. So if you check your handout, this is the one I'm working from here. So it would, can't see that. We'll zoom it in a little bit. So you'll recognize this if you look in your notes. It's 3 solution prep, and then solution phase reactions are given down here. Okay, so from this set, number 1, prepare 500 milliliters of 1.5 molar sodium hydroxide solution. Solution from manufactured stock, purity factor is 98%. So the idea is, how much pure of the manufactured stock do you need to extract and dilute to 500 mils? Well, the mass in grams needed is equal to molarity times volume in liters times formula weight divided by the purity factor. So the molarity that we need is 1.5 molar. Remember, that's moles over liters. And the volume in liters is 0.500 liters. Formula weight's 40 grams per mole. And the purity factor is 98% and should be expressed in the formula as a decimal fraction. So liters will cancel out, moles will cancel out, and you're left with grams. So I get 30.6 grams of sodium hydroxide manufactured stock needed. So you transfer 30.6 grams of the NaOH solid stock into mixing container, and dilute up to, but not to exceed 500 milliliters total volume. Now for number 2 in this set, prep 1500 milliliters of 2 molar HCl solution from a manufactured stock that's 37% active in HCl, and you're given the specific gravity of 1.14. What you need here is what volume of manufactured stock do you need, then dissolve and dilute to the 1500 mils. So this would be using the formula volume in milliliters needed is molarity times volume in liters times formula weight of the solute divided by the purity factor of the solute solution and specific gravity. So this one works out to, the molarity would be 2.0 molar. The concentration is 1.5 liters. Volume is, formula weight's 36 grams per mole for HCl. The purity factor is 0.37 and specific gravity is 1.14. which is the density of the stock solution in grams per mil. Now, the final units will be in milliliters for this. So calculation shows we'll need 256 milliliters of the concentrated HCl. Now, in preparing strong acid solutions, one should first dissolve this quantity in a small amount of water. Do never try to pour water on top of a quantity of acid like this, or else it'll overheat and possibly splash back in your face. So, method is dissolve, or add, I might say, add 256 milliliters of HCl 37% stock solution into 500 milliliters of solvent water, then dilute up to, but not to exceed, the 1500 mils. Total volume in that. So it's very important that you follow this procedure as a safety factor in preparation of strong acid type solutions. The third problem is application of the dilution equation. Molarity times volume of the concentrate is equal to molarity times volume of the diluted sample. So given 100 milliliters of 0.05 as the needed solution, then we can put that in 0.05 molar times 100 mils. Because the units are the same on both sides, you can leave it in milliliters. You do not have to use liters here. The volume is the unknown. Volume of the concentrate is what we're trying to calculate, times the molarity is a 2 molar stock solution. So solving this for the volume of the concentrate, 0.05 molar times 100 mils divided by 2 molar solution gives us a 2.5 milliliters of the 2 molar stock, and you can transfer this directly and then dilute it. So the prep method is transfer 2.5 milliliters of 2 molar NaOH stock solution into mixing container, and then dilute up to, but not to exceed, 100 milliliters total volume.